Mars. Mars is the closest planet to Earth and also the most potentially habitable among all 8 planets. Daytime temperatures are far less extreme than those on Mercury or Venus, occasionally rising to a pleasantly mild 20 degrees Celsius. But the real challenge lies in the nighttime, or in certain regions of the planet, where temperatures can plummet to a chilling minus 13 degrees Celsius. Another major concern, much like on Mercury, is Mars's extremely thin atmosphere. It's primarily composed of carbon dioxide, with only trace amounts of oxygen, making breathable air almost non-existent. This thin atmosphere also leads to low air pressure and dangerously high radiation levels. Naturally occurring radiation on Mars averages between 24 to 30 rAds. That's about 40 to 50 times more than Earth's typical exposure. To make things tougher, Mars is known for its intense and frequent dust storms, with wind speeds reaching up to 100 kilometers per hour. These violent storms could create serious obstacles, meaning any form of human habitation would demand a fully sustainable, airtight, and highly insulated life support system. Jupiter. Jupiter is the biggest planet out of the 8, and it's one of the hardest planets to land on, primarily because of its extreme radiation levels even 300,000 kilometers away. The radiation would start penetrating your suit and you'd be done for. But since that's a boring outcome, let's assume you have a hypothetical suit that can block the radiation. Jupiter's gravity is 2.4 times stronger than Earth's, meaning you'd be falling incredibly fast as you enter the first layers of the atmosphere. You'd encounter white clouds made of frozen ammonia, crystals with temperatures around minus 150 degrees Celsius. The winds here are no joke, reaching insane speeds of up to 482 kilometers per hour. If you manage to descend about 150 kilometers through these top layers, you'd reach the deepest point ever explored. This is how far NASA's Galileo probe got back in 1995. Beyond this point, things start getting darker, and both temperature and pressure increase rapidly. Just as a fun fact, the pressure near Jupiter's center is estimated to be about 100 million times Earth's atmospheric pressure. After hours of falling, you might reach Jupiter's inner layers, where you'd encounter a supercritical fluid state. That's not quite liquid, but not gas either. Here, you'd kind of be swimming in this bizarre substance. If you continued further toward the center, you'd encounter metallic hydrogen, an extremely dense liquid that would trap you. But if you somehow managed to get through that, you'd reach Jupiter's core, though we're not entirely sure if it's solid or not. The temperatures here would be about 24,000 degrees C, roughly 4-5 times hotter than the sun's surface.